This is part 4 of section 8.5. Suppose that at age 25, you decide to start saving for retirement by depositing $75 at the end of each month into an IRA that pays 6.5% compounded monthly. How much will you have from the IRA when you retire at 65, and how much did you earn in interest? So this is an annuity. Our p-value, we are depositing $75. Our rate is 6.5%, so R is 0.065. Compounded monthly, so our end value is 12. Now for the time, well, we retire at 65, we start saving at 25, so our time must be 40 years. Okay. Now take all of this, plug it into our formula. $75 times 1 plus 0.065 over 12 to the NT. So 12 times 40 minus 1 all over 0.065 over 12. Now, if you enter this in your calculator and round to the nearest dollar, you get $171,271. Okay. How much did we make in interest? So these are like the previous problems. We first have to figure out how much we deposited, which would be $75 every month for 40 years, which comes out to $36,000. So how much did you earn in interest? That's going to be $171,271 minus $36,000, which gives you $135,271 in interest. Okay, so just like with our other investments, we often have a goal in mind, and we need to figure out how much money to deposit to reach that goal in the specific number of years. We did this type of problem in the previous 2 sections as well. So all of this formula is this formula here solved for P instead of A. So they really are the same formula, one's just been rearranged. And basically this works the same way as all the others. We're going to be plugging into this formula and figuring out how much we need to invest starting now to reach our goal. And just like in the other problems, we are always going to be rounding up to the nearest dollar, just to make sure that we do end up having enough saved and we are not short by any amount. Okay? So determine the periodic deposit and round up to the nearest dollar, how much of the goal comes from deposits and how much from interest. Okay? So we want to end up with $150,000 after 18 years, and we can invest at 5% compounded annually. I'm just going to plug into this formula. So we need to know how much to deposit to end up with $150,000 times R over N. Our R is going to be 0.05 and our N value is 1, right? So that means just like in that previous problem, we don't have to write it down if we don't want to. And this is over 1 plus R over N, so it's 0.05 to the NT, which would be 1 times 18 minus 1. Okay. You want to enter this as carefully into your calculator as we did on the previous problems. and you find that your deposits need to be approximately, we're supposed to round up, so $5,332. Okay, now we're going to do the same thing we did before. We want to figure out how much we made in deposits, which would do 5,332 for once a year for 18 years. And if you multiply that out, you get $95,976. So how much did you make in interest? Well, the end goal is $150,000. And I subtract off the $95,976. So in interest, you made $54,024 in interest. Okay, so let's say we have a financial goal of $250,000 after 10 years, and this time is 7.5% compounded monthly. So we're looking for P. This is our A value. 10 years is our T value. This is R, which is 0.075 compounded monthly, so our N value is 12. Now I'll just plug it all in. I have $250,000 times R over N. So get things out of the way here. R over N, 0.075 over 12, all over 1 plus 0.075 over 12 raised to the NT, so 12 times 10 minus 1. Okay, good. So we get approximately, we're always supposed to round up, even though that's a 0, there's stuff after that decimal point, so we round up to 1406. So that's how much money we should invest every month. How much did we end up depositing overall? Would be 1406 every month, so 12 for 10 years. And that gives me $168,720 that we have deposited. Subtract to get the interest, which is $81,280.